Hello there, and welcome to The Sleepy Scientist. Tonight we drift far beyond the familiar worlds of our solar system, beyond the bright spirals of galaxies and into the quiet space between them. Out here, the universe feels wider, darker, and more patient. And yet even in this deep silence, the cosmos is not empty. It is gently connected by something vast and delicate. A hidden structure made of faint gas and dark matter, stretching across unimaginable distances. This is the cosmic web, the slow intergalactic network of filaments that quietly links galaxies together like soft threads in the dark. Before we begin, allow yourself to settle comfortably. Let your shoulders soften, your hands rest easily, and your breathing slow down without effort. There is nothing you need to focus on, and nothing you need to remember. Whatever belonged to the day can fade quietly into the background, becoming lighter with each calm breath you take. Intergalactic filaments are among the largest structures in the universe, but they are also among the most gentle. They do not shine brightly, they do not move quickly. They exist as faint rivers of matter, guiding galaxies through slow gravity over billions of years. Between these filaments are wide, quiet cosmic voids, regions so empty and still that they feel like deep silence made real. As we continue, we'll explore the most relaxing facts about the cosmic web. We'll observe how these filaments form, what they're made of, how they shape the growth of galaxies, and why the universe looks like a vast, quiet network when seen on its largest scale. These facts are not meant to excite or overwhelm. They are meant to slow your thoughts, soften your attention, and guide you gently toward rest. If you enjoy these calm journeys through the gentle side of science, you're always welcome to subscribe and return whenever you need quiet curiosity or peaceful sleep. But for now, allow your awareness to drift outward into the deep intergalactic dark where invisible threads connect distant galaxies and the universe holds itself together in calm, silent balance. Let's begin. Intergalactic filaments are part of what scientists call the cosmic web, and the calmness of this idea begins with the scale of it. When you look at the universe on the largest distances, you do not see matter scattered randomly. You see a quiet pattern, like an enormous three-dimensional net. Galaxies gather along faint threads, and between those threads are wide open voids. The cosmic web is not loud or fast. It is a structure that took billions of years to form, shaped slowly by gravity, and it continues to evolve so gradually that it feels almost still, as if the universe is resting in its own gentle architecture. The cosmic web is made mostly from dark matter, an invisible substance that does not emit light but still has gravity. This is one of the most soothing scientific facts because it suggests that the universe is held together by something quiet and nean. Dark matter forms the underlying scaffolding of the cosmos, and ordinary matter, the gas that becomes stars and galaxies, settles into that scaffold over time. The web is like a soft framework that you cannot see directly, yet it guides everything. It reminds you that the universe can have structure without needing brightness, and that invisible things can still create calm order on the larger scale. Intergalactic filaments contain large amounts of gas, often hydrogen and helium, spread thinly across space. This gas is so diffuse that it would feel like almost nothing compared to air on Earth, yet it stretches across millions of light years. In these filaments, matter is not packed tightly. It is gently distributed, drifting through deep space. The calmness comes from imagining gas moving not as wind, but as a slow presence, a faint river of particles flowing under gravity's subtle pull. It is a universe where even streams are quiet, where motion is measured in millions of years and distances are measured in the space between galaxies. Between the filaments of the cosmic web are cosmic voids, immense regions with very few galaxies. These voids are some of the quietest places in existence, not just because they have less matter, but because they represent a kind of stillness built into the universe's structure. If the filaments are the threads, voids are the spaces between them, vast and open, like dark rooms in the architecture of space. These voids remind us that emptiness is not a mistake or a gap. It is part of the pattern, part of the calm balance between structure and space. The cosmic web formed from tiny fluctuations in the early universe, small differences in density that existed shortly after the Big Bang. At first, the universe was almost uniform, but not perfectly. Some areas had slightly more matter than others, and over time, gravity amplified those differences. Regions with a bit more matter gently pulled in more, becoming denser, while emptier regions became voids. This is a calming story because it is not about sudden creation. It is about slow growth. The web was not built in a moment. It emerged gradually, like a slow pattern forming in soft material, guided by gravity's patient pull over billions of years. Galaxies tend to form and grow at the intersections of filaments, where matter collects more strongly. These intersections are sometimes called nodes, and they are like quiet gathering points in the web. Gas flows along filaments toward these nodes, feeding galaxy formation and providing material for new stars. The calmness comes from imagining galaxies as part of a gentle supply network. They are not isolated lights floating randomly. They are connected by slow streams of matter, and their growth is influenced by the calm structure of the universe itself, as if gravity is quietly delivering ingredients to the places where galaxies can thrive. Intergalactic filaments are not solid structures. They are regions of slightly higher density than their surroundings, shaped like long, faint tendrils. They can be tens to hundreds of millions of light years long, yet still incredibly thin compared to their length. This makes them feel delicate, like threads stretched across a vast room. Even though the cosmic web holds much of the universe's matter, it remains subtle. It does not shine brightly like stars. It exists mostly in darkness, revealed only through careful observation and patient science. That subtlety makes it feel peaceful, because the universe's largest structure is also one of its quietest. Scientists study the cosmic web in several calm and indirect ways, including the gentle technique of looking at how light from distant quasars passes through intergalactic gas. As quasar light travels across the universe, it passes through filaments and clouds of hydrogen. That hydrogen absorbs specific wavelengths, leaving faint fingerprints in the spectrum. This pattern is called the Lyman alpha forest, and it is like a quiet map of the web traced in delicate absorption lines. There is something soothing about learning the universe's structure through the soft dimming of light, as if the cosmic web reveals itself not by brightness, but by tiny shadows imprinted on ancient photons. The cosmic web also influences how galaxies spin and align, because matter flows along filaments in organized ways. Galaxies are not only connected by location, but often by motion. Gas and smaller galaxies can fall into larger structures along filament pathways, shaping the growth of galaxy clusters. This happens slowly, in gentle gravitational steps. It is like a long migration through space, guided by invisible currents. Even collisions and mergers, when they occur, are often part of this slow gathering process, unfolding over hundreds of millions of years, making the entire evolution of galaxies feel like a calm, inevitable settling into the web structure. Perhaps the most relaxing truth about intergalactic filaments is that they show the universe is quietly organized on the largest scales. Nothing in the cosmic web is rushed. Nothing is abrupt. Gravity shapes it over billions of years, drawing matter into soft threads and leaving wide voids between them. Galaxies shine within this network like lanterns along distant roads, and the filaments themselves remain mostly invisible, present as faint rivers of gas and dark matter. The cosmic web reminds us that even in the deepest darkness, there is structure, connection, and gentle balance, holding the universe together in calm, steady silence. Intergalactic filaments feel calm because they are not objects that rush through space. They are slow structures, shaped by gravity over long time, and they change so gradually that they seem almost timeless. A filament can stretch across tens of millions of light years, connecting clusters of galaxies like a quiet bridge, and yet the material within it is incredibly thin and delicate. The density of gas in a filament is far lower than anything we experience on Earth. It is more like a faint presence than a substance, a gentle trace of matter stretched across darkness, reminding us that the universe can be structured without being crowded. The cosmic web is often described as the universe's large-scale structure, and that phrase itself carries a soothing meaning. It suggests that the universe has a natural arrangement, as if space has been gently woven into patterns. In this view, galaxies do not simply float alone. They follow the web's pathways, gathering along filaments and settling into clusters where filaments intersect. This creates a sense of calm order, because even across unimaginable distances, matter follows simple rules and forms repeating shapes, like a quiet geometry written into the cosmos by gravity and time. Most of the ordinary matter in the universe is not locked inside stars and galaxies. A significant fraction is found outside them, in intergalactic space, spread through the cosmic web as warm and hot gas. This gas is often called the warm-hot intergalactic medium, and it can exist at temperatures ranging from tens of thousands to millions of degrees. Even though that sounds hot, it is still extremely diffuse, so it does not behave like heat on Earth. In space, temperature reflects the energy of particles, but the particles are so spread out that they rarely collide. The calmness comes from imagining a thin, quiet medium drifting through space, carrying energy without fire, warmth without flames, existing as an invisible background that stretches between galaxies. Intergalactic filaments are not only routes for matter, but also for the slow growth of galaxy clusters. Over billions of years, gravity gently draws gas and galaxies along filaments toward the densest regions. This creates clusters, massive collections of galaxies bound together. The motion is slow and quiet, like a deep current in a cosmic ocean. Galaxies drift inward over long spans, not racing, not colliding constantly, but moving gradually through space as gravity guides them. Even when clusters form, they do so through patient gathering rather than sudden appearance. The cosmic web contains patterns that can be seen in computer simulations, and these simulations are one of the calmest ways to visualize the universe. In a simulation, particles representing matter begin nearly evenly distributed, and over time they clump together into threads and nodes. Watching this happen is like watching frost form on a window or seeing ink spread slowly through water. Structures emerge naturally, without forceful intervention, simply through the steady influence of gravity. The web grows from gentle differences into a vast network, showing how complexity can arise from quiet rules repeated over long time. Filaments are often traced by galaxy surveys, where astronomers map the positions of millions of galaxies across the sky. When these maps are viewed in 3 dimensions, the cosmic web becomes visible as a pattern of connected chains and sheets. What feels soothing is the way the universe looks almost like a living network, not because it moves quickly, but because it has a shape that seems to breathe and stretch across space. The galaxies are like glowing beads, and the filaments are the invisible string between them. Even though these structures are immense, they are built from gentle connections, repeating over cosmic distances. The cosmic web is thought to contain not only long filaments, but also wall-like structures, sometimes called sheets. These sheets are broad regions where galaxies and gas align in flatter formations. Where sheets intersect, filaments form, and where filaments intersect, clusters form. This layered hierarchy feels calming because it suggests the universe builds itself in quiet levels, like a slow architecture. Instead of one single shape, there are nested patterns, each one emerging from the same gravitational rules. The web is a calm framework where matter settles into forms that are both simple and vast. Light travelling through the cosmic web can be gently altered by the gas within filaments. Neutral hydrogen, for example, absorbs specific wavelengths, creating subtle signatures in the light from distant sources. This is how astronomers detect filaments indirectly. The The process is peaceful because it involves listening to faint patterns in light rather than relying on bright images. Photons move through space for billions of years, passing through thin gas, and when they reach us, they carry delicate information about every region they crossed. The cosmic web reveals itself through tiny absorption features, like quiet fingerprints left on ancient light. The cosmic web also influences the temperature and density of gas around galaxies, affecting how galaxies form stars. Gas flowing along filaments can feed galaxies, delivering fresh hydrogen that can eventually cool and collapse into star-forming regions. This feeding process is slow and gentle, like a long supply line across space. It is not an aggressive flow like a river on Earth. It is more like a gradual drift, guided by gravitational slopes across the universe's landscape. This slow delivery of gas helps galaxies continue forming stars over time, linking the calm structure of filaments to the quiet glow of starlight. Cosmic voids, the empty spaces between filaments, make the filaments feel even calmer by contrast. Void regions can span tens or even hundreds of millions of light years with very few galaxies. Within a void, matter density is low and gravity is weaker. Things move slowly, and there is little to disturb the stillness. Voids are like vast, silent rooms in the universe, emphasizing how gentle the cosmic web is. The filaments are not crowded highways. They are faint threads in a mostly empty space, giving the whole universe a sense of spacious quiet. Perhaps the most relaxing truth about intergalactic filaments is that they show how the universe is connected without being noisy. The cosmic web holds galaxies together in a vast network, guiding matter through slow gravity, forming clusters and superclusters over billions of years. Filaments carry gas, dark matter, and faint structures through deep space, while voids provide open stillness between them. It is a universe built like a calm tapestry, woven slowly from invisible threads, where light travels quietly along long distances and galaxies glow gently at intersections, held in place by gravity's steady, patient hand. Intergalactic filaments feel calm because they are shaped by the slowest kind of motion the universe offers, motion that takes billions of years to become visible. When we picture the cosmic web, we are not picturing something that forms in a moment or changes in an instant. We are picturing a pattern that emerges gradually, like a gentle structure rising out of near uniform space. The filaments are not solid ropes. They are faint regions of slightly higher density, where dark matter and gas have collected quietly under gravity, forming long threads that connect the bright islands of galaxies across enormous distances. The cosmic web is often described as the universe's scaffolding, and that word is soothing because it suggests support rather than force. Dark matter forms a framework of gravity that ordinary matter follows. Gas flows toward denser regions, and where it collects, galaxies can form. This is calm because it means the universe does not build itself from chaos alone. It builds itself from a quiet underlying pattern, an invisible structure that gently guides matter into its long, connected shape. Even though the web is huge, it is built from soft rules repeated endlessly, making the cosmos feel stable and patient. Filaments can stretch for tens to hundreds of millions of light years, and yet they are extremely thin compared to their length. This gives them a delicate quality, like threads stretched across a vast dark room. The gas inside a filament is so diffuse that it would be closer to a vacuum than any air we know. Even dense parts of the intergalactic medium are sparsely populated by particles. The calmness comes from realizing that these massive structures are not heavy walls or solid bridges, but faint concentrations of matter, barely there, yet still enough to shape galaxies and clusters through gentle gravity. Galaxies do not just sit inside the cosmic web, they move within it slowly, drifting along the filament paths like leaves carried by a deep, slow current. Over cosmic time, small galaxies can merge into larger ones, and groups of galaxies can fall toward clusters where filaments intersect. This gathering happens gradually, guided by the gentle slope of gravity within the web. The universe does not hurry this process. It takes millions and billions of years, making it feel like an enormous slow settling. The cosmic web becomes less like a battlefield and more like a calm landscape where matter slowly finds its place. The cosmic web contains not just filaments, but also nodes, where filaments intersect and where galaxy clusters form. These nodes are among the densest regions in the web, and they can contain hundreds or thousands of galaxies bound together. Yet even clusters are peaceful when viewed at the right timescale. They are not flashing or exploding constantly. They're steady collections, slowly evolving and gently reshaping through gravity. The intersection points of filaments are like quiet gathering circles, where matter accumulates gradually, building structures that last for billions of years. Gas flowing along filaments can also be heated as it falls into deeper gravitational wells. When gas is pulled toward clusters, it can become compressed and warmed, sometimes reaching very high temperatures. But because the gas is so diffuse, the heat is not felt as warmth in a familiar way. It is simply energy in widely separated particles. The calmness is in imagining hot gas that is still silent and thin, drifting through space without glowing brightly. Much of this gas emits faint X-rays, but it remains almost invisible compared to starlight, adding to the sense that the web is powerful yet quiet. Intergalactic filaments can also influence the orientation and spin of galaxies. The flow of gas and the movement of smaller galaxies along filaments can supply angular momentum, shaping how galaxies rotate and how their disks align. This means the cosmic web is not only a map of where galaxies are, but also a gentle influence on how they evolve. The calmness here is that even galaxy rotation can be tied to slow, steady cosmic flows. A galaxy's spin may partly reflect the quiet direction of matter, drifting along a filament long before that galaxy fully formed. The cosmic web is sometimes described using the language of rivers and valleys, and this metaphor is soothing because it makes gravity feel like a gentle landscape rather than a forceful pull. In this view, filaments are like valleys of gravity where matter tends to flow, and voids are like high plateaus where matter is sparse. Matter drifts downhill into the filament's nodes, slowly settling in denser regions. This gentle flow does not require speed. It happens naturally, guided by the shape of gravity across vast space. The universe becomes a calm terrain, where matter simply follows the easiest path over deep time. Observing filaments directly is difficult because they are faint, but scientists have developed calm methods to detect them. One way is through gravitational lensing, where the gravity of matter, including dark matter and filaments, slightly bends the light of distant galaxies. By measuring small distortions in the shapes of background galaxies, astronomers can map the distribution of mass, revealing faint filament structures. This is soothing because it shows how the web can be sensed through gentle bending of light, like a quiet ripple in the universe's geometry, rather than through bright emission. Another way to study the cosmic web is through the distribution of neutral hydrogen, especially in the early universe. Hydrogen gas in filaments can absorb light from distant sources, leaving patterns in spectra that reveal where matter lies between us and the distant object. This method lets scientists trace the web across long stretches of time, seeing how filaments existed when the universe was younger. The calmness comes from the idea that the web is ancient and persistent. It existed early, it shaped galaxies gradually, and it continues today, slowly evolving as the universe expands. Perhaps the most relaxing truth about intergalactic filaments is that they represent connection without noise. The cosmic web is a quiet network of dark matter and gas stretching across the universe, linking galaxy clusters like soft threads across a dark sky. It forms slowly from small early differences, guided by gravity's steady pull, and it changes over billions of years. Between the filaments are vast empty voids, adding space and stillness to the pattern. The cosmic web reminds us that the universe is not only filled with bright objects, but also with gentle structure invisible pathways and calm order written into the darkness itself. Intergalactic filaments feel calm because they are the universe's quiet way of creating structure without needing brightness or noise. When we imagine the cosmic web, we are imagining a pattern that exists on the largest scales, where gravity shapes matter into threads, intersections, and wide empty spaces. These filaments do not shine like stars, and they do not move quickly like storms. They exist as faint concentrations of dark matter and gas, stretching across millions of light years, changing so slowly that their evolution feels more like a steady presence than an event. They are the background architecture of the cosmos, holding galaxies in gentle connection. One soothing fact about the cosmic web is that it is three-dimensional, like an enormous lattice in space rather than a flat pattern. From a human perspective, we often see maps of galaxies as if they were drawn on paper, but the real universe has depth in every direction. Filaments extend through space like long corridors, and voids open out like immense rooms. This makes the cosmic web feel like a quiet cosmic landscape you could drift through endlessly, with threads of matter forming subtle pathways and open empty regions, creating deep silence between them. Intergalactic filaments can carry gas towards galaxies in a process sometimes called cold accretion, especially in the early universe. In this scenario, relatively cool streams of gas flow along filaments into galaxies, feeding star formation without being shock-heated to extreme temperatures first. This is calming because it imagines galaxy growth as something nourished gently, like slow streams delivering material to a growing system. Even though the scales are enormous, the concept remains soft. The universe feeds its galaxies gradually, through quiet flows along invisible threads rather than through sudden violent processes alone. The cosmic web changes with time because the universe is expanding, and expansion itself can feel calming when you picture it as slow and steady rather than dramatic. As space stretches, galaxies move farther apart on average, and voids grow larger. Filaments remain connected, but they also evolve, thinning and stretching as matter continues to drift inward toward denser nodes. This means the cosmic web is not frozen in place. It is slowly breathing outward with the universe, while gravity gently pulls matter inward. This balance between expansion and attraction creates a calm tension, like a fabric being stretched while its threads still hold together. Clusters of galaxies at filament intersections can contain vast amounts of hot gas, known as intra-cluster medium. This gas can glow faintly in X-rays, and it can fill the space between galaxies inside a cluster. Even though the gas is hot, it remains extremely thin and quiet, spread over millions of light years. The calmness comes from how different space is from Earth. Heat does not mean fire or burning sensations. It simply means particles with energy moving in silence. In clusters, galaxies drift through this thin, hot gas, moving slowly under gravity, like lanterns floating through a quiet haze. Intergalactic filaments can be shaped by the way dark matter collapses under gravity. Dark matter clumps first because it does not interact with light and can begin gathering early, creating the gravitational wells that ordinary matter later follows. This is soothing because it suggests the universe builds itself from an invisible foundation. The most important framework is silent and unseen, and the bright parts of the universe, the stars and galaxies, are like decorations that appear later, settling into the calm scaffold already laid out by dark matter. The cosmic web is like a hidden skeleton supporting everything quietly. Filaments also help explain why galaxies are not evenly distributed across the sky. When astronomers map galaxy positions, they find chains, clusters, and gaps. These patterns are the visible parts of the web. What feels peaceful is realizing that the emptiness between galaxy groups is not a mistake or absence of creation. It is a natural part of the cosmic pattern. The voids are just as important as the filaments because they define the shape of the web, creating spaciousness and calm separation between the denser threads. Gas inside filaments can sometimes be detected through faint emission from ionized hydrogen or other elements. This detection is extremely difficult because the light is weak, but with sensitive instruments, astronomers can sometimes see hints of glowing gas bridging between galaxies. It is calming to think that the cosmic web can appear as faint glowing mist, a barely visible thread of matter stretching across darkness. Even when it becomes visible, it does not shine like a star. It appears gently, like a dim fog illuminated by distant sources, revealing structure without overwhelming brightness. The cosmic web can also influence the way galaxies merge and interact. Galaxies often travel along filament pathways, and when they reach denser regions, they may encounter other galaxies more frequently. This can lead to mergers, which shape galaxy growth over time. Even this process is calm on the cosmic timescale. A galaxy merger can take hundreds of millions of years, unfolding slowly as two systems spiral together. From the perspective of the universe, it is not a sudden crash. It is a gradual dance, guided by gravity, happening quietly while stars continue to shine steadily within their galaxies. Cosmic voids are some of the most peaceful environments because they contain fewer galaxies and less matter overall. Inside a void, gravitational forces are weaker and matter is sparse. A traveller drifting through such a region would see very little, mostly darkness and distant galaxies far away. This emptiness is not frightening when imagined calmly. It is like an enormous quiet space where nothing interrupts stillness. Voids expand as the universe grows, becoming even larger, reinforcing the feeling of wide silence between the threads of the cosmic web. Perhaps the most relaxing truth about intergalactic filaments is that they reveal the universe as a connected system rather than a scattered collection of isolated lights. The cosmic web is a calm network of dark matter and gas, stretched across space like invisible threads. Galaxies gather along these threads, clusters form at intersections, and vast voids provide open stillness between them. The web forms slowly from tiny early differences and continues to evolve gently as the universe expands. It is the universe's quiet architecture, holding everything together in steady balance, reminding us that even the largest structures can be delicate, patient, and softly woven into the darkness. Intergalactic filaments feel calm because they are structures made more of influence than of substance. They are not walls or solid bridges. They are gentle pathways where gravity has guided matter into long, faint threads across the universe. The cosmic web does not announce itself with brightness. It exists mostly in darkness, revealed through subtle patterns in galaxy positions and soft signatures in distant light. When you imagine the web, you're imagining something that has taken billions of years to form. A quiet arrangement of matter that stretches so far that even the concept of motion feels slow and softened by time. One soothing fact about the cosmic web is that it emerged from an early universe that was almost perfectly smooth. Soon after the Big Bang, matter was distributed very evenly, with only tiny differences in density. Those tiny differences were like gentle ripples in the fabric of the cosmos. Over billions of years, gravity slowly amplified them, drawing slightly denser regions into filaments and nodes and leaving underdense regions as voids. This means the web began as something almost imperceptible and then gradually became the universe's structure. It is a calm story of growth, where small beginnings slowly become large patterns without needing sudden events. Intergalactic filaments are sometimes described as the places where baryonic matter, the normal matter made of atoms, is most likely to be found outside galaxies. A large fraction of this baryonic matter exists in the intergalactic medium, distributed along filaments as gas. This gas can be warm or hot depending on where it lies within the web. Even when it is hot, it remains extremely thin. Particles are spaced far apart and collisions are rare. This creates a peaceful vision of hot matter that does not roar or blaze, but simply exists as faint invisible energy spread through emptiness. The cosmic web has a gentle hierarchy. Smaller filaments feed into larger ones, and smaller groups of galaxies fall into larger clusters. This is similar to how streams flow into rivers, and rivers flow into larger bodies of water, except the timescales are cosmic. The calmness comes from that natural shape. The universe organizes itself into levels of structure, and each level grows from the one before it. Nothing has to be forced. Gravity provides the guidance, and matter follows, creating a calm network that looks almost organic, as if the universe naturally prefers connected shapes. Galaxies located within filaments often have access to more gas than galaxies isolated in voids. This extra gas can influence how long they continue forming stars. In a quiet way, filaments act like gentle supply lines, delivering material slowly through space. Star formation may still happen in bursts inside galaxies, but the long-term availability of fuel can depend on these calm intergalactic flows. It is soothing to think that a galaxy's glow may be supported by an invisible thread of gas stretching across millions of light years, quietly delivering hydrogen over deep time. The cosmic web can be traced through gravitational lensing, which is one of the softest ways the universe reveals itself. Dark matter and gas bend space slightly, and that bending changes how we see distant galaxies behind them. The effect is subtle. Background galaxies appear slightly stretched or distorted. By measuring many galaxies, astronomers can map the invisible mass between us and them, revealing filamentary structures. This is calming because it shows that the web can be sensed through gentle changes in shape, like a quiet whisper in the geometry of light, rather than through bright images. Intergalactic filaments also influence the temperature of gas falling into clusters. As gas flows inward along filaments, it can be compressed and heated, forming warm-hot intergalactic medium that fills the filaments and cluster outskirts. This heating happens gradually, like air warming as it sinks into a valley, except in space it is gas responding to gravitational compression. The calmness is in the slowness and subtlety. Even when the energy is high, the gas remains faint, mostly invisible and silent. The web holds energy without drama, maintaining quiet conditions across enormous distances. In the early universe, filaments were likely more active in feeding galaxies because star formation was more intense overall. Younger galaxies needed more fuel, and filaments provided pathways for gas to flow into growing structures. Over time, as galaxies evolved and the universe expanded, the balance shifted, but filaments still remain important channels of matter. This long history feels soothing because it shows continuity. The cosmic web has been shaping galaxy evolution for billions of years. It is not a temporary structure, it is a long-lasting framework quietly guiding matter from the early universe to the present. Cosmic voids grow larger over time as the universe expands, and this makes the web appear even more pronounced. Matter gradually drains out of voids and into filaments and nodes, leaving voids emptier and more spacious. This creates an image of the universe slowly separating into quiet emptiness and connected threads. Voids are not failures of structure, they are natural expansions of space where gravity is weaker and matter is sparse. Their growth adds to the calmness of the cosmic web by increasing the sense of open, silent space surrounding the filaments. Intergalactic filaments can host faint magnetic fields, likely generated by cosmic processes such as early universe plasma effects, or later amplification through galaxy and cluster activity. These fields are extremely weak, but they can influence how charged particles move in intergalactic space. The calmness here is that even magnetism, which can sound forceful, becomes subtle at these scales. It exists as a gentle influence, shaping motion in quiet ways without visible drama, like invisible lines of direction woven into the cosmic web itself. Perhaps the most relaxing truth about the cosmic web is that it shows the universe as a softly connected place. Galaxies are not isolated, but arranged along invisible threads of dark matter and gas that stretch across space. These filaments form slowly from tiny density ripples. They feed galaxies with gentle flows of matter, and they guide clusters to grow at intersections. Between them, voids provide vast silence and open darkness. The cosmic web is the universe's calm design, a structure built not with sudden force, but with patient gravity and deep time, holding everything together in quiet balance. Intergalactic filaments feel calm because they are the kind of structure you can only notice when you step back far enough. Up close, the universe looks like individual stars and galaxies scattered across darkness. But on the larger scales, a gentle pattern appears, like a woven network stretching through space. The cosmic web is not something that forms quickly or changes suddenly. It is the long-term result of gravity's slow shaping of matter, turning tiny early differences into threads, nodes, and wide, quiet voids. It is a reminder that the universe can be organized in the most peaceful way, through steady rules repeating over billions of years. One soothing fact about the cosmic web is that it contains most of the universe's matter in a form that is not bright and not easily seen. The galaxies we notice first are only small concentrated islands. Much of the normal matter exists as gas between galaxies, and dark matter forms the majority of the mass shaping the web. This means the visible universe is only a small part of a much larger quiet structure. The idea feels calming, because it suggests that the universe is not defined only by what shines, but also by what quietly holds everything together, unseen but steady, like a hidden framework supporting the lights we can see. Filaments are sometimes compared to roads or bridges, but in reality they are more like gentle slopes in a gravitational landscape. Matter drifts into them because they represent regions where gravity is slightly stronger than in voids. This drift is slow, like a soft migration rather than a flow. Gas and galaxies move along these pathways with quiet inevitability, pulled by gravity across immense distances. The calmness comes from imagining the universe as a landscape where matter simply follows the easiest path over time, settling into filaments the way water settles into valleys, without needing force or urgency. The cosmic web is also connected to the way the universe looks like foam on its largest scales. In this picture, voids act like the empty bubbles, and filaments and sheets form the edges between them. This foam-like structure emerges naturally in simulations and observations. It is soothing because foam is a gentle and familiar pattern, soft and repeating, with spaces enclosed by thin boundaries. The universe becomes a calm cosmic foam, with galaxies gathered along the walls and threads, and the larger spaces kept empty and still. Gas within intergalactic filaments can be partially ionized, meaning its electrons are separated from atoms. This ionization often occurs because of ultraviolet light from galaxies and quasars, as well as shock heating from structure formation. Even when ionized, the gas remains extremely diffuse, with particles separated by vast distances compared to air on Earth. The calmness here is that intergalactic gas does not behave like a storm or a fire. It is simply a faint medium, quiet and thin, drifting in darkness, carrying gentle traces of energy without noise. Filaments can have temperatures that vary along their length. Some regions hold cooler gas, especially far from dense clusters, while other regions contain warmer gas as matter falls toward larger gravitational wells. This creates gradual transitions rather than sharp boundaries. The cosmic web is full of gradients, slow changes in density and temperature. These gradients are calming because they suggest smoothness. The universe does not always separate into strict categories. It often blends slowly from one condition into another, like a quiet fade in light, creating a continuous and gentle structure across space. The cosmic web can influence how galaxies evolve by affecting their environment. Galaxies inside dense nodes may experience interactions and mergers more often, while galaxies along filaments may be more isolated but still connected to a supply of gas. Galaxies in voids may have fewer neighbours and less fresh gas flowing in. This means the web is not just a pattern in space, but a quiet influence on the life cycle of galaxies. It shapes how often galaxies meet, how much material they receive, and how their star formation slowly changes over time, all guided by the calm structure of their cosmic surroundings. Astronomers sometimes detect the cosmic web by looking for faint absorption patterns in the light from distant objects. When light from a quasar passes through filament gas, hydrogen absorbs specific wavelengths, leaving a pattern that reveals the presence of matter. This technique feels soothing because it is gentle. The universe reveals itself through tiny dips in light, subtle and quiet, rather than through bright flashes. The cosmic web becomes something you sense like a whisper through the quiet filtering of ancient photons that have travelled billions of years to reach us. Filaments can also contain smaller structures called subfilaments, thinner threads feeding into larger ones. This creates a nested network where matter is organised at multiple levels, like a branching system. This branching is calming because it feels natural and organic. Many calm structures in nature, like river networks or tree roots, have similar branching shapes, and the cosmic web shows that gravity produces these patterns even across cosmic distances. It makes the universe feel gently familiar, built from the same quiet principles of flow and connection that appear in smaller systems. Cosmic voids, by contrast, are regions where matter is so sparse that galaxies are rare and far apart. Voids can be incredibly large, and within them, gravitational forces are weaker. Matter drifts slowly outward as the universe expands, leaving the void even emptier. This emptiness is calming because it is not chaotic. It is a stable quiet. A void is like a wide open silence between the filaments, making the filaments feel like soft boundaries rather than dense walls. The web becomes a pattern of gentle connection floating in vast stillness. Perhaps the most relaxing truth about intergalactic filaments is that they represent quiet connection across the largest scale imaginable. The cosmic web forms slowly from early density ripples, shaped by dark matter scaffolding in the gentle pull of gravity. It carries gas toward galaxies and clusters, organizes matter into threads and nodes, and leaves wide voids as calm open spaces. It is not a structure of noise or urgency, but one of deep time patience, where the universe arranges itself like a soft network in darkness, holding galaxies together in a steady invisible weave. Intergalactic filaments feel calm because they are the universe's way of making order without disturbance. They are not made of bright walls or solid material, but of subtle gravitational shaping, where matter gathers gently into long threads over billions of years. The cosmic web is quiet because it is mostly invisible. It holds galaxies in place, guides gas across deep space, and creates enormous patterns without sound or speed. When you imagine a filament, you're imagining a faint bridge of matter that stretches across darkness, existing patiently, changing so slowly that it feels like a permanent part of the universe's background. One soothing fact about the cosmic web is that the densest regions of filaments can slowly funnel matter into galaxy clusters. Clusters are the largest gravitationally bound structures in the universe, and they often form at intersections of multiple filaments. The slow feeding of clusters is a calm process. Gas drifts inward along the filament's gravitational pathways, and smaller galaxy groups slowly join larger ones. Even though the mass involved is enormous, the process unfolds quietly over hundreds of millions to billions of years, like a slow gathering rather than a sudden event, giving the universe a sense of patience and inevitability. The cosmic web also plays a role in the way galaxies get their fuel for star formation. In many models, gas streams along filaments and accretes onto galaxies, supplying the hydrogen needed to form new stars. This is a gentle image, because it suggests galaxies are nourished by slow cosmic flows rather than built in isolation. Filaments become calm supply lines, carrying faint, diffuse gas through the darkness, feeding the glow of galaxies over long time. Even star formation, which can seem energetic, depends on a slow, quiet delivery of material guided by the structure of the web. The gas in filaments is often described as the warm-hot intergalactic medium, and this medium is one of the quietest forms of matter. Even when it is hot by temperature standards, it is so thin that it produces little light. Particles may travel long distances before colliding with another particle, and the gas behaves more like a faint mist than anything dense. This is soothing because it shows that the universe can hold energy without drama. Heat does not always mean brightness. In the cosmic web, Energy can exist in silence, spread thinly across space, almost imperceptible unless measured carefully. Intergalactic filaments can also be thought of as places where matter is slightly more structured than in voids, but still far less concentrated than in galaxies. In a galaxy, stars are packed closely enough to form bright spirals or glowing elliptical shapes. In a filament, matter is spread out over millions of light years. This creates a calm gradient of density. The universe transitions smoothly from bright concentrated islands to faint extended threads, and then into deep empty voids. These gradual transitions are soothing because they feel natural, like the universe is softly blending rather than sharply dividing. The cosmic web has been confirmed in observations through large galaxy surveys that map the positions of galaxies across enormous volumes of space. When these surveys are visualized, galaxies appear clustered into lines, arcs and walls, with large empty spaces between them. What feels peaceful is how consistent these patterns are. The web is not random, it appears again and again in different surveys, showing that the large-scale universe has a stable, repeating form. The universe becomes something you can trust to have structure, even in its vastness, because gravity produces the same quiet patterns across time and distance. Filaments can also be traced through this distribution of neutral hydrogen in the early universe, which leaves a signature in the light from distant quasars. The Lyman alpha forest appears as a series of absorption lines, each one marking a region where hydrogen gas absorbed part of the light. These lines are like gentle shadows, telling us where filaments and gas clouds existed along the line of sight. This is calming because it shows that the universe reveals its structure through softness. We do not need bright images to know the web exists. We can sense it through delicate imprints on ancient light, as if the cosmos quietly writes its patterns into the photons travelling through it. The cosmic web is also a place where small galaxies can be influenced by their environment. A galaxy drifting along a filament may experience mild interactions with other galaxies or gas, shaping its evolution slowly. It may merge with another galaxy over a long time, or it may be stripped of some gas as it approaches a cluster. These changes happen gradually. On human timescales, everything looks still. But on cosmic timescales, the web is gently guiding galaxy evolution, slowly arranging matter into larger structures without needing sudden events to reshape the universe. Voids within the cosmic web are often expanding and becoming emptier with time. As the universe expands, matter tends to drift away from void regions and into denser filaments. This creates a calm picture of emptiness growing deeper. Voids are like wide, quiet basins where matter is scarce, and over time they become even more open. This emptiness is soothing because it represents silence on the largest possible scale. A void is not chaos, it is calm space, almost untouched, providing a deep backdrop for the filaments and the galaxies that rest along them. Intergalactic filaments may carry weak magnetic fields that thread through the cosmic web, gently influencing charged particles. These fields are faint and difficult to measure, but they may have been seeded in the early universe and later shaped by structure formation. The calmness here is that magnetism at this scale is subtle, not like a strong field you can feel. It is an invisible, gentle influence, guiding particles quietly and adding another layer of delicate structure to the web, like faint lines woven into the fabric of intergalactic space. Perhaps the most relaxing truth about the cosmic web is that it shows the universe as a connected system built from patience. Dark matter forms an invisible scaffold. Ordinary matter follows, filaments grow slowly, and galaxies gather where threads meet. Gas flows gently along these pathways, feeding star formation and cluster growth over billions of years. Between the threads, vast voids expand into deep stillness. The cosmic web is the universe's calm architecture, a quiet network of connection and emptiness, holding the cosmos together with slow gravity and deep time balance. Intergalactic filaments feel calm because they are the universe's quiet way of connecting everything without needing to be seen. The cosmic web is mostly invisible, made of dark matter and faint gas, yet it shapes the positions of galaxies across space like a gentle framework. Nothing in this web forms quickly. Nothing moves with urgency. The filaments took billions of years to emerge from tiny early density ripples, and they continue to evolve so slowly that the change is almost like a whisper over deep time. When you imagine these structures, you imagine a universe that builds itself patiently, creating order through calm repetition. One soothing fact about the cosmic web is that it can be thought of as a kind of cosmic geography. Just as Earth has mountains, valleys and basins shaped by gravity and time, the universe has regions of higher and lower density shaped by the same principles. Filaments act like valleys of matter where gas and galaxies drift slowly, while voids act like high plateaus of emptiness. This metaphor is calming because it makes the universe feel like a landscape you can slowly glide across, rather than a chaotic space filled with random objects. Matter follows the contours of this cosmic terrain, settling gently into filaments over long periods. Filaments often appear connected in branching patterns, where smaller filaments feed into larger ones, forming a network that resembles natural systems like river basins or tree roots. This similarity is soothing because it suggests that simple physical rules can create familiar shapes at every scale. On Earth, water follows gravity and creates branching rivers. In the universe, matter follows gravity and creates branching filaments. The cosmic web becomes another example of nature's calm tendency to form networks, where flow and connection are built slowly and continuously rather than suddenly and forcefully. The gas inside filaments is often a mixture of hydrogen and helium with trace heavier elements, and it can be enriched over time by material flowing out of galaxies. Galaxies can release gas through stellar winds, supernova-driven outflows, and active galactic nuclei. Some of this material escapes into intergalactic space and becomes part of the filament medium. This is a calm cycle because it describes a slow exchange between galaxies and the space around them. Galaxies are not closed systems. They gently breathe material outward, and filaments hold that material in faint streams, creating a quiet recycling of elements across the cosmic web. In denser parts of the web, especially near clusters, the gas can become shock-heated as it falls inward under gravity. This heating happens as gas accelerates toward dense regions and compresses, raising its temperature. But even this heating is calm in its outcome, because the gas remains thin and quiet, radiating energy slowly. It does not glow brightly like a star. It emits faintly, often in X-rays, and is difficult to observe. The web can be energetic yet remain peaceful, because its energy is spread across enormous volumes of space, never forming the sharp, bright intensity of a small localized source. The cosmic web also plays a role in the way galaxies are distributed in time, because the pattern we see today is not the pattern that existed in the early universe. The web has grown more defined as gravity gathered matter into filaments and nodes. In the early universe, the distribution of matter was smoother, and galaxies were forming more rapidly. As billions of years passed, filaments thickened, clusters formed, and voids expanded. This slow evolution is soothing because it suggests the universe is always shaping itself gently, never rushing, always moving towards structure in a gradual way, like a slow settling of dust in still air. Filaments can sometimes be detected through the faint glow of hydrogen emission, especially when gas is illuminated by nearby galaxies or quasars. This glow is extremely weak, but when detected, it reveals filaments as barely visible threads of mist between galaxies. The calming part is that even when the cosmic web is seen, it appears soft and subtle. It does not dominate the sky. It is like a faint fog stretched across space, almost more imagined than seen, making the universe feel quiet and delicate, with structure that is present without being overwhelming. As this quiet journey through the cosmic web continues to echo softly in your mind, there is nothing you need to hold on to, and nothing you need to follow. The universe can remain vast and connected without needing your attention. Its invisible filaments, its deep voids, and its slow gravity will continue their steady balance whether you think about them or not. You may notice your thoughts becoming lighter now, less defined, like distant galaxies fading gently into the background. That is perfectly natural. Intergalactic space does not rush toward conclusions, and your mind does not need to reach one either. Everything can remain open. Everything can remain calm. Let your breathing stay unforced and easy. Let your shoulders rest. Let your hands remain still. Imagine those faint threads of matter stretching quietly across the darkness, linking distant galaxy clusters like soft pathways of gravity. Between them, picture the wide cosmic voids, open and silent, holding more space than the mind can easily measure. Nothing out there demands effort. Nothing calls for urgency. Everything simply exists in slow, patient order. The cosmic web reminds us that even the emptiest parts of the universe are not truly empty, and even the darkest spaces can still be connected by gentle structure. It is presence without pressure. It is distance without loneliness. It is a quiet architecture that holds galaxies in place while allowing the universe to expand calmly outward, one slow moment after another. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel heavy, you're always welcome to return. The universe will still be here, woven together by invisible threads, unfolding gently in the background just as it always has. For now, allow the quiet to remain. Let the filaments fade into softness. Let the vast darkness feel steady and safe, and let whatever comes next arrive naturally. Good night.